Bismillahir Rahmanir Rahim. Centripetal force. The centripetal force is a name given to the net force required to keep an object moving on a circular path. Or, the centripetal force is a force which keeps a body to move in a circle. The direction of the centripetal force is always towards the center of the circle, and it continuously changes the direction as the object moves. The formula for the centripetal force is Fc is equal to mv square over r, where m is the mass of the object, v is the speed of the object moving in a circle, and r is the radius of the circle. Before going to the mathematical derivation of the formula for the centripetal force, we elaborate two basic concepts: that acceleration can be due to the change in direction, and secondly, similar triangles have the same ratio between their corresponding sides. So first of all, acceleration due to the change in direction. It is very important to note that if an object is moving with a constant speed, for example, if an object starts from here and it covers a distance of 2 meters in 1 second, and then it changes its direction towards right and then covers a distance of 2 meters in 1 second, then its speed is 2 meters per second. And if he claims that I have a velocity also of the value 2 meters per second, then he is wrong, as actually he has displaced himself from starting point to the finish point, which is less than 4 meters. And let me say this is 3 meters. The actual displacement is not 4 meters. So change in displacement in total 2 seconds is 3, not 4. So velocity is actually 3 over 2, 1.5 meters per second. His speed is 2 meters per second, but his change of displacement, he is not displacing at the speed of 2 meters per second. He is displacing at the rate of 1.5 meters per second. So his velocity is changed because of the direction only. Speed is same, but the direction is changed, and that is the reason for changing the velocity. Initially, his velocity was 2 meters per second, but due to change of direction, its velocity becomes 1.5 meter. So there is a change of 0.5 meter per second, and change of velocity is known as acceleration, and change of velocity has occurred in 2 seconds, so its acceleration is 0.25 meter per second. So just because of changing the direction, a body can have an acceleration but its speed remains same. This is one concept which will be used in the next slides, so please remember it. Secondly, you also note that if two triangles are similar, and what are the similar triangles? Any triangle having two angles same. For example, these two triangles, these are right angle triangles, so one angle is 90. And if other two angles, this angle and this angle is 60, the third angle will be 30, as total angle is 180. If this is 90, this is 60, then the remaining angle will be 30. So if all the angles are, at least two angles of triangle are equal, then their shape will be similar. They are not equal triangles. These two triangles are similar triangles, not same triangles. These are similar in shape. So when the triangles are similar in shape, by having same angles, triangles are similar in shape, then their ratio between the corresponding sides is always equal. For example, ratio of their bases, a ratio of their heights, a ratio of their hypotenuse remains same. And also the ratio of the perpendicular to the base means 3/2 will be equal to ratio of the perpendicular to base 9/6, that is also 3/2. 9/6 is equal to 3/2. So in similar triangles, the ratio of the sides, corresponding sides, remains equal. Okay, these two concepts. One, the velocity can change because of the direction change. And second, similar triangles have same ratio in their corresponding sides. These two concepts we will use in the next slides in the proof of formula for the centripetal force. Now we start the derivation, mathematical derivation of the centripetal force formula. Consider a body is moving in a circular motion with a uniform speed or a constant speed. In uniform speed in a circular motion, the speed is constant but velocity is continuously changing as the body is changing its direction. And we have already discussed, when the velocity of the body changes, when the direction of the body changes, its velocity changes. So at point O, it's the body, it starts and reaches the point P. At point O, body has a direction in. At point O, body has in this. At point O, the velocity of the body is in this direction, and at point P, the velocity of the body is in downward direction. So direction of the velocity is changed, and because of the direction change, the net velocity will be different. Net velocity will change. It means the body will have acceleration. Change of velocity is known as acceleration. What is acceleration? We will calculate in the next slide. But in this slide, you note that if angle between the radius of two positions is theta, then the angle between their corresponding velocities, pink vector and brown vector, if we draw the brown vector at the starting point O, it means that the initial velocity and the final velocity have an angle of beta. And if you see this figure, then alpha plus beta is equal to 90. Alpha angle plus beta angle. And alpha plus theta is also 90, as right angle triangle, total angle is 180. Over here is 90. The remaining two, the sum of remaining two is equal to 90. It means that if we equate these two equations, then we get beta is equal to theta. It means that beta, it means angle between the velocity vectors and the radius is same. If it is theta, then over here is theta. Here is an angle of 30 degrees, then beta will be 30 degrees. So now we prove the mathematical formula for the centripetal force. For verification of derivation of the formula, we know that F is equal to ma. And first of all, we have to calculate the centripetal acceleration. And centripetal acceleration is derived over here. Centripetal acceleration is v square over r. How it is derived? Let me see. As a body is moving in circular motion, and in this position, if we see over here, this can form a triangle, AOACB triangle. And these two sides, radius, OC radius and CP radius, form this radius and this radius. And if we join these 2 points O and P, means A and B, then it will be a triangle. This triangle is formed by the radii. Two sides are radii. And another triangle can be made by using the velocity vectors, pink vector and the brown vector downward. And we can see that the black vector represents the change in velocity. Initial velocity is the peak velocity, and after adding the change we will get the final velocity. So this is a change of velocity. These two triangles are not equal triangles. These are made geometrically or graphically, but these are not equal triangles. These are similar triangles. How these are similar? You can see there are three angles. All the three angles of triangle are equal. First of all, we see this angle. This is theta over here, and we know that the angle between pink and brown vectors is also theta, as discussed in the previous slide. This beta is also theta. So beta is also theta, pink and brown vector. The angle between pink and brown vector is theta or beta, same. So two angles are same, and triangles will be similar if all the three angles are equal. First angle is theta, and other two angles are equal. For example, if this is 80 degrees, theta is 80 degrees, then the remaining two angles will be equals, and total angle is 180, and this is 80 degrees. The remaining 100 will be divided in these two, 50 degree and 50 degree, as total angle is 180. Over here is 80. Let me consider this is 80 degrees, then the remaining will be divided into 2, as two sides are equal, and angle opposite to the sides, equal sides will be equal. These are two equal lengths, so angle will be equal. Angle in front of red line and angle in front of black line. Both angles depend upon the length of side. Lengths are same, so angles will be same. Similarly, magnitude of velocity vectors is same, so lengths are same, and angle in front of pink vector will be equal to angle in front of red vector. As magnitudes of lengths are same, velocities are same, angle in front of these two, this angle and this angle in front of red, will be same. If this is 80 and total angle is 180, so 50 over here and 50 over here. It means that these two triangles are similar triangles. And when there are two similar triangles, it is very well established fact that the ratio between their corresponding sides, any two sides of the corresponding triangles, the ratio between any two sides will be equal. So we take the ratio of delta V to V. We take the ratio. Why we take, I tell you a little bit later, but we take the ratio delta V over V. Over here, that will be A to B over any one side. Okay. So now we move towards this over here. We know that acceleration is equal to change in velocity per unit time, and time can be taken by, for general formula, distance over velocity. Any body which I have covered a distance of s with a velocity v, with a speed v, then we can get the time, how much time it has spent. That can be taken by dividing total distance by total speed. So these are two general formulas, and by putting the value of delta t over here, we get acceleration equal to v into delta v over s. And also we have seen that delta v over v, ratio of two sides of these two similar triangles, delta v over v, ratio of these two sides, will be equal to AB over R. Any two sides of similar triangles, the ratio of any two sides of similar triangles will be equal, as triangles are scaled up 1 time, 2 time, 3 time or 4 time. For example, this triangle is scaled up, or this is bigger triangle. How many times? 3 times. Its base is 2, its base is 6, it means 3 times. Its perpendicular is 3, its perpendicular is 9, 3 times. Hypotenuse is 4, hypotenuse 12, it means it is 3 times bigger. So it is scaled up to 3 times. So ratio will be 1/3. Any two sides, ratio of any two sides will be between the corresponding. And similarly, the ratio between their own two sides will be same. You can take it for 3/2 will be equal to 9/6. Means 3/2. So ratio of any two sides in the similar triangles will be same. So delta V over V will be equal to AB over R. And using this, you can see that AB is equal to S. AB and arc length S are almost same when delta T approaches to 0 at any smaller interval of time. These are same distances. So we replace AB with the S, and you can see that delta V over S, just you put S in the denominator by cross multiplication. Delta V over S is equal to V over R. Now put the value of delta V over S over here. That will be equal to V square over R. So now we have derived the formula for the centripetal acceleration, and you note that we have not fully mathematically derived this formula only, but we have also taken the advantage of geometry or geometrical or graphical relationship. By using graphical relationship or graphical derivation, we see that the ratio between two sides will be same, and from this mathematical relationship we took the advantage and we calculated the centripetal formula, centripetal acceleration. Now when we have calculated the formula for the centripetal acceleration, you can calculate, you can measure, you can become known with the centripetal acceleration. How much is the centripetal acceleration of a body rotating in a circle? Just you can know, you measure the velocity or speed, you measure only the speed and radii of that motion, and you will have a centripetal acceleration. Now as we know that any force, net force, when is applied on a body and that is moving with some acceleration, that force can be calculated using the formula F is equal to ma, and we know that acceleration, centripetal acceleration is equal to V square over R. So by putting the value of V square over R, we get the centripetal force. Now we calculated, or we derived the formula for the centripetal force, and we also know that V is equal to R omega. V is equal to R omega, put the value of V, R omega, and simplified. This is another formula, this is another shape for the centripetal force. Thank you for watching the video. Please visit the website www.cancollit.com and also subscribe this channel for more informative lectures and videos. Thank you.